Alright, in this video I want to go ahead and put together a basic project, a console project that uses all of the components that we stubbed out just to give people an idea of how these individual components are going to work together and how an actual client would look, whether that client be from a console or a WPF app or a website and so on. However, there are a couple of things with the stuff that I do want to take a look at. I do want to introduce a couple of more bits of functionality into the iClient transport interface. Particularly, I want to have a standardized way of determining if a particular transport has connected or not. In addition, I also thought a lot about this, and I think I want to move the iEventReader module and the addEventReader methods into the iClient transport interface itself. Because the reason I didn't do that previously was I was thinking that maybe that particular implementation might be it might be something that you might want to change sometime in the future. But the more I thought about it, the more I kind of decided that this sort of interface for adding event readers into the client transport is something that we would want, or is a good enough abstraction. It's not such a high-level abstraction as to prevent you from doing something that you wanted to do. And so I tried to sit down and think of a use case where I would want the iEventReader module concept to only live within certain transports, and I decided that I kind of want this concept to live with any transport that we were to write, be it a in-memory transport or using a different network framework or your own network framework or whatever. So I want to go ahead and move these two classes into their own files because now they're no longer specific to the client transport base. So to do that, pretty easy. I'm going to go over here to the client project in the infrastructure namespace. I'm going to create a class, and I'm going to call it, or create an interface first. I'm going to call it iEventReader module. And then all I'm going to do really is I'm just going to take the code within iEventReader module that's within our client transport base and just cut and paste it over here, and then make sure that I import my systems collections generic. Now I won't import event reader module registration because we're going to be moving that class as well. Anyway, now that we've moved over iEventReader module, let's go ahead and remove the interface definition from client transport base and do the same thing that we just did with event reader module registration. So I'm going to open up my Solution Explorer, go to infrastructure, create a new class, and I'm going to call it event reader module registration, exact same name, exact same members, all that fun stuff. And then all I'm going to do is I'm going to take the innards of this class, Control X, and paste them over into the event reader module registration. And of course I'm going to have to import system so I can get action. I'm going to have to import collections generic so I can get dictionary, and I'm going to have to import base infrastructure to get event code. Now that I've done that, be sure to remove event reader module registration from client transport base to prevent potential confusion. So now that we have that done, the final step would be to go into iClient transport and add a method addEventReader so that it's part of the interface and not just the base class. Before I do that though, I want to go ahead and introduce two new members or two new types into the infrastructure namespace. And these types are going to be responsible for dealing with when the transport connects. So basically, like I said, I really wanted to, I noticed that iClient transport was fairly anemic and didn't do a whole lot, and I decided that the concept of listening to its status changes as well as listening to events is something that I wanted to move up into that interface. So the two types I want to throw in, one's going to be an interface, and well, let's do the enum first actually, because the interface is going to need the enum. The enum I want to add is transport status, or how about client transport status to keep the verbiage similar. And the two members I want on this enum are connected and disconnected. Yes, I could use a Boolean, or I could just use an enum. I mean, it doesn't really matter. I mean, we could go ahead and also make the backing type of this enum a byte. It's sort of pretty irrelevant, but I guess we'll save, 3 bytes by doing that because the enum backing type will default to int. So now that we have a client transport status, let's jump back into our infrastructure namespace and create a new interface. And this interface is going to be iClient transport listener. And the iClient transport listener interface is simply going to have one method called client, or how about transport status changed, and it'll take one parameter of client transport status, and that will be called status. So the point of this is this interface will be implemented by members that want to keep track of when the transport connects and disconnects. When we move to horizontally scaling with multiple servers, the client transport is going to become a lot more complicated because the client transport is really going to be the thing that handles this whole multi-server infrastructure, and we'll definitely be having to do a little bit more work in our iClient transport listener. But for now, the only event that I'm particularly interested in handling is the transport status changed, so that we know when the transport connects, we can do something, like initialize our client context or whatever. Now that we've done that, we can move over into the iClient transport and actually make those changes. So the first thing I want to do is I'm going to basically be moving up from the client transport base. I'm going to be moving the add event reader method up. One way to do this would be to make sure your keyboard cursor is on this identifier right here and hit Control-Shift-R and say pull members up. That's one way to accomplish that. Another way would be to simply go into the iClient transport and just type in the name exactly. So add event reader, event reader module. Let's match the parameter name as well, event reader. So to verify that you have this correct, go back to the client transport base and make sure there aren't any errors. Because if there are any errors, that means that you misspelled or mistyped something. Now I want to go ahead and introduce another method that hasn't been implemented on the client transport base. And that's going to be the add listener. And it's going to, the add listener method is going to take in an iClient transport listener, and the name of that parameter is listener. The final thing I want to do is I want to add a void disconnect. While disconnect was already present on the Photon client transport, I wanted to add it to the iClient transport because having a way to listen in to the connection status of a transport without a way of disconnecting seems a little lopsided to me. So I wanted to go ahead and move the concept of disconnecting up into the interface itself. Okay, now that we've done that, we're going to get a couple errors inside of our client transport base. And the reason for that is that we've introduced these two new methods in our interface, but we haven't implemented them. So let's go ahead and stub those methods out. I'm going to place these methods underneath send operation, but before our protected methods, because I typically like public members being before private members. There are times where I won't do that, but in this case, I think that'll be the cleanest way to do this. So what I'm going to do is I'm going to add a public void add listener, iClient transport listener. And then I'm going to add a public virtual void disconnect. So not all transports are going to have a concept of disconnecting. Like, for example, an in-memory client transport won't have a concept of disconnecting. So I'm just going to leave it virtual, and I'm just going to make it up to the inheriting classes to decide whether they want to implement that method or leave it blank. The final thing I want to do, just because our class stubs, we've included all private fields, I want to go ahead and add the private field that we're going to need for our client transport listeners. So up here at the top, I'm going to add a new private read-only. Now, there's a couple ways to do this. I could make this a list, but I think what I'm wanting to do here is actually make this a hash set. And the reason I want to make it a hash set is that a hash set will only allow unique objects within it. So for example, if we tried to add the same client transport listener twice to it, we'll only have one instance. Furthermore, hash sets are very efficient at things like adding and removing members and ensuring no duplicates. And there's a possibility that we will want to add a mechanism for removing a listener in the future. At this point, I don't see the point of doing that, so I'm not going to worry about it. But either way, I like using hash sets for my listener code. So, or for things that like event handlers and stuff like that. And it's going to be a hash set of iClient transport listeners, and we're going to call this listeners, just underscore listeners. The word client transport I try not to use within a class that's called client transport, so we're just going to say listeners. Alright, so now that we have that pretty much all figured out, what I'm going to do now is I want to go ahead and create a console application, and I want that console application to instantiate and configure all of these objects as if we're actually creating a an actual project. As if we're actually creating a client. I want to show you guys the steps that you would do to put all these classes together to get a client behavior. And I think that'll help in understanding how these little pieces fit together so that when we go to implement them, things will make a little bit more sense. So I'm going to close all my documents out. Inside of this solution, I'm going to right-click the solution and say Add New Project. And I'm going to select Console Application. Sure, let's make it .NET 4.5.1. It doesn't really matter what version of .NET as long as it's above 3.5. So the name of this application is going to be buzzmmo.client.console. And the purpose of this particular project is mostly just going to be for testing purposes to make sure we can connect without having to get all messy with Unity. We might put some things like stress testing and other fun stuff in the console application. It's mostly just going to be a throwaway application that we use for whatever purpose we need it for. But either way, go ahead and add it. And the problem with that is that off screen I had already done that, and since I'd already done that, there's already a folder there, which I don't want. I'm going to go ahead and just delete this folder, and you guys just can pretend like that didn't happen. Alright, so now that we have the client console, first thing we need to do is add our references. So there's a handful of references we're going to need to add. I'm going to right-click References, and I'm going to select Add References. We're going to start with the assemblies within the solution that we need to reference, because we have a bunch of these projects. The only ones that we really need to reference for a client are going to be base and client, and that's it. So let's go ahead and hit OK. Next up, there's another handful of things that we're going to need. So I'm going to right-click and select Add Reference again. But in this case, I'm going to go ahead and Browse. I'm going to click Browse. And underneath so if you back all the way up into your solution root, underneath this, you have your lib folder. Inside of lib folder, we're going to need our Photon server log4net. And I'm going to hit Add. In addition, we're also going to need our client.net Photon3.net DLL. So we need our log4net and our Photon3.net DLL. Then I'm going to hit OK. Okay, so what are the steps for creating a actual usable client? Well, basically, we're going to need a couple of things. First of all, we'll need a system base. So remember how we have this, we have our system base on our server, our client system base tick3 right here. Well, our clients need to be a little bit more flexible than that, because I don't want to ever enforce that the class hierarchy of a client system inherits from a particular class. And the reason I don't want to do that is because our components in Unity are going to be mono behaviors, and they're going to be inheriting from mono behavior. So we need a lot of flexibility in how we implement systems. The way that I chose to handle that was to put the concept of the system base within the specific client that we're going to be working with. And I think that's a great way to deal with that problem. So we're going to need a system base. We're also going to need a kind of a context class. You can kind of think of it like the root of the entire system. And the reason for that is I really, really, really want to avoid as much as possible using singleton classes to share information and behavior across the application. And to do that, the best way to go about doing that is to kind of create this sort of root object that contains all of the systems within it. And the reason that's a good idea is because if we can get this context instance into our systems and into our actors and so on, the code that we write for our systems or our actors can reference that root object and then by extension reference the entire system without having to depend on any static code. And I really like that sort of concept. So you'll notice that I do use the word context a lot to refer to a handful of different things. And really what I mean by the word context is sort of a root object for a particular class hierarchy, is effectively what I'm trying to express. So each client is going to have their own context, and it's going to be specific to that client. That's another important thing about this design. A WPF application its context might have a reference to the main window that's open, so that systems can reference the UI. A Unity project may have a reference to the game object that represents the player in its context, and so on. So the context is really important, and it's specific to the client. Another thing that we're going to need, just as kind of a type-safe syntactical kludge, is going to be an interface that our systems implement. And really, that's about it. And there's not a whole lot of other things to say, other than we also will need something that handles our initialization of a player. And we don't have any code that does that quite yet, so I'm not going to worry about that. But anyway, so let's go ahead and start off with just writing a couple classes. So inside of our client console, I'm first going to start off with a console context class. And I'm writing this class first, but I'm not going to fill it up with anything, because I think, in fact, this is probably going to be the last class that we implement, but I need it because we're going to be referencing it from other parts within the within this class structure. So we need the class there so we can reference it, but we're going to fill it out as a last step. Next up, we need our iConsole system base. And the iConsole system base is basically provides a type-safe way for us to reference any system within the console application. And what I'm going to do here is I'm going to add a single method, and it's going to be void set context, console context. So the iConsole system base is an interface that allows us to populate that console system with a context. Now we could add other things. If this were a Unity project, for example, we might want to add a game object property that refers to the current game object that system's in, and so on. Next up, we need a system base, and that system base is going to be responsible for being the base class for our system. So I'm going to say, I'm going to call this console system base tick2. And of course, I'm going to remove the tick2 at the end of that because that's not a valid class name. We just want the tick2 on the file. It'll be a generic type, and it'll take in a T server and a T client, just like what we did before. It's going to implement two interfaces. First of all, it's going to implement iSystem base, which comes from base infrastructure, passing in T server and T client. Next up, it's going to implement iConsole system base. Now let's go ahead and provide our implementations. So we need a public type, and type, of course, is going to come from the system namespace. And then we want server system interface type with a getter, and the getter will return type of tserver. Then we need public type, client system interface type, get return type of tClient. I'm actually trying to come up with a way to remove having to have these two properties on systems, but we'll leave that for later. Next up, we're going to have two protected fields, a protected tserver proxy and a protected console context. Then we're going to have our public virtual void dispose method. We're also going to have a protected virtual void awake method. And then finally, we're going to have a... Now, I did actually mess up the iConsole system base, and forgive me for doing that, but what I'm going to do here is I'm going to say public void set context, and it's going to take in a console context, and an object proxy. And it's going to say context equals context, proxy equals cast to tserver, proxy, and then it's going to invoke awake. And that's really what all the console system base is. So as every client that you're going to create, you're going to need a system base class. And so this is what our very, very rudimentary console system base class looks like. Now let's go ahead and fix our iConsole system base, because the set context method is going to also accept a proxy. So I'm going to say object proxy. And now our console system base compiles. And then remember, it evokes awake after it's initialized its context and proxy. Okay, that's really about it. I do want to make sure that I didn't mess up one thing, though. Under systems, our iSystem factory... actually, no, we didn't mess that up, I don't think. No, we didn't. Okay, sweet. No, did we? Yes. We did mess it up. The problem is remember our activator system factory within Buzz MMO client systems? Unfortunately, this init system method, or action, is going to be a delegate that this factory will invoke every time a system is created. And that's how we're going to invoke our set context method, which you'll see very shortly here. But if you look at the parameter list of this delegate, you'll notice it only takes in a tsystem base. But in addition to that, I also want to send the proxy. So I'm going to do tsystem base and object. So our init system method takes in two parameters, the system base class itself, or interface in this case, as well as an object that represents the proxy. So make sure to make that change, otherwise code won't work as we try to write it. Okay, so now what we do is we can work on our console context, because remember, our console context class brings everything together. So our console context class can have two private read-only fields. It's going to have an iClient transport, and we're going to say underscore transport. It's going to have a public client systems, and we'll call this systems. And it's going to have a public system type registry, and we'll call this type registry. Then it's going to have a constructor. Now the constructor is going to take in two things. It's going to take in an iSerializer called serializer, and it's going to take in an iClient transport called transport. The first thing we need to do is set our private transport to the transport that was passed in. All right. Now we want to create our systems. How do we create our systems? What things do we need to create the systems module? Well, we need a type registry. But the only place the type registry is used is in our activator. So it's possible that we can create different system factories that don't require the type registry component. Then we need our systems factory. So I'm going to say system factory equals new activator system factory. For the generic parameter, I'm going to pass in iConsole system base as the generic parameter. Then for its arguments, I'm going to pass in the type registry, and I'm going to pass in init system, which is a method that I'm going to write on the client context that I haven't written yet, and we'll get to that here in a second. Now we need to do two things. We need to instantiate our systems. So I'm going to say systems equals new client systems. We need to pass in a component map. So I'm going to say new component map. We need to pass in a system factory, which we already have, because it needs to know how it can create systems. Then we need to pass in an iSystems operation writer. So we're going to instantiate a systems operation writer, passing in our serializer and our transport. We can make this a little bit cleaner by factoring out these variables. I'm going to say systems components, and then for the operation writer, I'm going to say systems operation writer. So hopefully how these classes interact is becoming a little bit more clear. We have our system factory, which is responsible for instantiating systems. We need a component map to know how to map with the transport, basically. We have our operation writer, which is responsible for telling the transport about system events. And then we have our actual systems. We're missing one thing. We've told the client systems how it's going to talk to the server, but we haven't told the system how the server is going to talk to our systems. So to do that, I'm going to say transport.addEventReader. I'm going to pass in new, and I think I know what's wrong with this. Yeah. Remember our client project in our systems namespace, our systems event reader? I didn't update it to have the class be outside of the client transport base. Let's fix that. Just remove the client transport base qualifier, and we're good. All right, so now that we've done that, we're going to say transport.addEventReader, and I'm going to instantiate a systems event reader, passing in the serializer and then the systems. And that's really the process that we're going to go through for each one of the modules that we add, whether it's a world module or something about counters or whatever. We just instantiate the main module thing, the client systems. We pass in a way for it to talk to the server, and then we add it to the transport through addEventReader. And that's how we plug into the transport, basically. There's one more thing that we need to do, and that is the console context is going to listen to the transport, at least the transport status. So I'm going to say subscribe to transport, and it's going to say _transport.addListener this. Now you'll notice that this is going to fail because we don't actually implement iClient transport listener. So let's go ahead and do that. On console context, I'm going to say I'll implement iClient transport listener. So now we can add a listener and we can be notified of status changed events. Now let's go ahead and add that method. So go ahead and add an empty method on your console context called transport status changed that takes in the transport client transport status. Then finally, we're going to need to do our init system. So the signature of init system is going to look like this. It's going to be private void init system. It's going to take an iConsole system base system and an object proxy. So this init system method will be used as a way to initialize an instantiated system. So I'm going to say system.setContext, passing in the context itself and passing in the object proxy. All right. The only other thing that we might want to do is we currently have this operation, and I'm actually not sure exactly how I'm going to go about doing this, but we have this init context operation code. I'm thinking what I'm going to do is I'm going to create a new module called something like a player that's specific to a particular client, and it'll handle the sending that operation, and when we receive a connection, we will invoke that method on that module. But either way, well, I guess we can probably do that now, because that's going to be something that we will need to do. So what we can do is, remember, we need to add something that when we establish a connection, it needs to send information to the server. And that's going to be client specific, because Unity might send something different than WPF, than an admin. We might need to authenticate at this level. For example, if we're in Unity, we might want to authenticate as running inside of the editor and get additional privileges. Or we might want to authenticate using an API key. So what I'm going to do is I'm going to create a new module, basically, that's going to plug into this system. And it's going to be called a console player module, or a player module, or something like that. So inside of the BuzzMO client console, and yes, what I'm about to show you guys is how you extend this system. So inside of this, I'm going to add a new class, and it's going to be called player module. Now the player module is going to have to implement iEventReader module. And by implementing this interface, we're going to have a public IEnumerable event reader module registration get registrations. And I'm simply going to say yield break. At this point, we're not going to actually add in any registrations. So we're not going to listen to any events, but we might want to. There might be some events that are specific to dashboards or to players or to elevated players, and this is where you would put the code that would handle those events. For the constructor of the player module is going to be something like we're going to get a client context, or console client context, or console context, and we're going to get an iClient transport. And we're just going to initialize both of these parameters to corresponding private fields. So we have our context and our transport. We're not quite done yet, though, in the constructor. In the constructor, I also want to say _transport.addEventReader this. So remember, the addEventReader is going to query the getRegistrations method. In this case, it's going to return no registrations, but in the future, we may want to. Now what we need to do is I'm going to go ahead and say public void init player. What I'm going to do is I'm going to say var parameters equals new dictionary byte object. I'm going to say parameters at cast to byte operation parameter dot context type equals context type dot player. Then I'm simply going to say _transport.send operation code init context, passing in parameters. And that's it. So now that we've done that, we have our new player module. So again, this is how you would plug in. You'll notice something interesting about the player module compared to the systems module. You'll notice that in a systems module, we have one method that performs the write operations, such as telling the server what to do, performing that serialization. And we have another class that's responsible for reading the data. You might be thinking, well, look at the player module. He does both. He listens to events, potentially, and he also sends operations. So why didn't I do that with the server content, or the client systems? The reason I didn't do that is the client systems is not a trivial class. It's a very large class that has a bunch of different, very important things in it. And I didn't want to add the responsibilities of handling events and sending operations into the client systems. So now you might be wondering, well, why didn't I just have the client systems and then have another class that performs the operations and the events, one that reads and writes to the network stream as another class that manipulates the client systems. And the reason for that is the circular dependency we will have. See, the class that writes to the network stream needs to be instantiated and sent into the client systems as a constructor parameter, right? And then we also need to be able to add the event reader, and the event reader is going to need a reference to the systems. So the thing that reads data needs to know about the systems object. The thing that writes data needs to be given in to the client systems object. So you have a circular dependency. There's no way around this other than separating their responsibilities. So you have the systems operation writer and the systems event reader. So you have two different classes with two different responsibilities. If we were to combine them, we would have a nasty circular dependency that would only be resolved by adding, let's say, a property that you initialize after the fact, which I didn't want to do. So instead I did it like this. Either way, the player module is, since it's so small and it's very specific to the concept of reading and writing data, I'm just going to leave this as both a write and both a class that writes to the operations and reads from the events. Okay, so back into the client context, how do we wire up our player module? It's actually pretty straightforward. The first thing I'm going to do is I'm going to add a new private field. I'm going to say private read-only player module, and I'm going to call this player module. Then inside of the constructor, after I set the transport, I'm going to say underscore player module equals new player module, passing in this as the context, and passing in transport as the transport. That's it. Because remember, the player module registers himself as event readers, so we don't need to do that after the fact. Now we've initialized the player module, let's go ahead and see how we would use it. So for example, in the transport status changed, what I'm going to do is I'm going to say if status does not equal connected return, then I'm going to say underscore player module dot init player. So once we connect, we initialize ourselves as a player, which kicks off the whole process on the server side. That's it. So again, this entire process would be repeated for any sort of module we might want to add. Or for simple modules like the player module, we just need to pass in ourselves in the transport. He'll do his own registrations and everything is all awesome. Okay, so the final thing I want to show you guys, or second to last thing I want to show you guys with this, is I want to show you guys how you would use this inside of a actual program. So let's go about showing how to write a program that uses this new client context. Well, the first thing I'm going to do is I'm going to do basic configurator.configure. Now, basic configurator comes from log4net.config. I'm doing this because the basic configurator will have all log messages printed to the console, which is exactly what we want. But that's just infrastructure. We don't need to worry about that. Now, the first thing we need to do is we need to instantiate our transport. So I'm going to say var transport equals new photon, or what did I call that? Photon client transport, which takes no parameters. Then we need to instantiate our context. So I'm going to say var context equals new client context, or console context, passing in a new instantiation of simple serializer as the serializer, and passing in transport as the transport. Then we say transport.connect, and we're going to pass in 127001 at port, I can't remember, 5055, we'll fix that later. And we'll connect to buzz MMO.server.master. Then I'm going to say while true transport.service thread, which comes from system.threading, sleep 10 milliseconds. That's it. So we instantiate our transport, we tell it to connect, we service our transport, and then we instantiate our context, which our context will create everything for us, all of our systems and all that fun stuff. The last thing I want to show you is how would you create a system, and how would you register a system for that matter. Well, registering a simple system is very simple. I just do context.typeRegistry.register, or how about scan assembly type of program.assembly. So this will register every system inside of the client console assembly, and that's how we register all our systems. Now, how do we create a system? Well, I'm going to create a new namespace in client console called systems, and I'm going to create a new class called login system. The login system is going to inherit from console system base, passing in I login system server as the first generic parameter, which this comes from BuzzMMO base components systems, and I login system client as the second. And it's also going to implement I login system client, which we'll need to implement basic client test. And we can just go ahead and put in an implementation here. We can do system.console.writeLine from login system. Actually, we can one-up this. We can say private static read-only ilog coming from log4net. Log equals log manager get logger type of login system. And then I'm going to say log.info format got message blank message. And that's it. That's how you tie into the framework. So assuming that everything was actually, well, assuming that we actually added implementation in our client framework, this would allow us to do that. So yeah, basically, our client framework is not implemented right now, obviously. But to use it, we just have a handful of steps. This whole iConsole system base thing is optional. The only reason I have this interface is so I can statically, within statically typed code, refer to the setContext method. If we wanted to use reflection instead, or if we wanted to create systems that didn't have contexts or proxies, which would make them kind of worthless, we could omit this entirely. Then we have our system base. Our system base is just a way to plug into any sort of framework that we want, be it Unity or whatever, that may have different constraints. So again, in Unity, we're going to have mono behaviors as our system base. And we can put in whatever base behavior that we want to give to our systems. Then we have our context. Our context is just kind of the root of the entire hierarchy. Context will have a transport, and in this case has a player module as our systems and our type registry. You know, we could even remove having the type registry as a property here and instead receive it from the constructor. Or we could receive the entire iSystem factory from the constructor, but there are some things that I wanted to do with the factory within the context itself. So we set our transport, we instantiate our player module so that we can initialize ourselves as a player. We create our systems framework, which is just a matter of making our type registry, creating our systems factory, creating our component map, our operation writer, instantiating the systems, adding it to the transport. That's it. Then we add ourselves as a listener. When we connect, we tell the player module to initialize himself. And when a system is created, we set its context. That's it. And with all this out of the way, the actual program itself is very, very straightforward. We instantiate our transport and then our context. We scan the assembly for all of our concrete system types. We connect, and then we service the transport. And that's it. So I'm hoping that you guys can see now how we can very easily write an in-memory transport. So that's something I'm really looking forward to. Once we get our systems implemented and we see that our console application is working, I'm going to go and actually write tests for this that use that are in memory, so that we can test a lot of this stuff within unit tests and not rely on a network connection. Because again, it all boils down to this transport, even though nobody knows its implementation. And I think that was one of my major goals when putting this system together. Anyway, I think that just about wraps things up. So I guess we will see you in the next video.